Hi everyone, this is Teacher Joanne and let's have another lesson in General Math. In this video, our focus is on one-to-one functions. What are our learning objectives? At the end of the lesson, you should be able to define one-to-one function, determine if a set of ordered pair or a function is one-to-one, and use horizontal line test to identify one-to-one function. To attain these learning objectives, the essential question that needs to be answered is how to identify if the given is one-to-one. First, let us define one-to-one function. When we say one-to-one function, the other term is injective, and it is a function for which every element of the range of the function corresponds to exactly one element of the domain. Looking at the figure at the right, as we can see here, we have a mapping that shows for every element of y, there corresponds one value of x, which makes this a one-to-one function. Next, when we say one-to-one, if x sub 1 is not equal to x sub 2, then f of x sub 1 is not equal to f of x sub 2. What does this mean? This means that if you have two different values of x, then it follows that you have two values of y that are different. Equivalently, if f of x sub 1 is equal to f of x sub 2, it is only when x sub 1 is equal to x sub 2, which means that if we have two y values, then it follows there is only a single x value. So this is the meaning of one-to-one. For one value of y, there is only one value of x. Let us now define one-to-one using set of ordered pairs. We have here a one-to-one example and a not example. The left side is one-to-one because every value of y there corresponds one value of x, while on the other hand, there is a value of y which is 6 that corresponds to two x values which are 5 and 8. So in general, in using set of ordered pairs, a function is one-to-one if y is paired with one x. Let's now have the graphs. Graphically, we can identify if the graph is one-to-one or not by looking at the y value, and you need to make sure that every y value has only one x value. The left graph is one-to-one. As we can see here, for one value of y, let's say negative 2, there is only one x value, which is at this point. Same is true for y, which is 4. There's only one x value that corresponds on this point. Unlike on the other graph, if we have one y value, let's say negative 2, there are two x values we have here at this point and on this point. And actually, we have a test that we could use, and that test is what we call the horizontal line test. What we mean by HLT? A graph of a function is one-to-one if each horizontal line intersects the graph in at most one point. So kindly just visualize if you are putting horizontal lines on this graph, the horizontal lines will only touch the graph at one point. Unlike on the other graph, if we have a horizontal line that will pass through this point, there are 2 points that will touch the graph. Going back to the concept of line test, we have the vertical and horizontal line test. Always remember that all functions satisfy the vertical line test, and all one-to-one functions satisfy both the vertical and the horizontal line test. How about using functions? To know if a function is one-to-one, we need to go back to the definition. Show that f of x sub 1 is equal to f of x sub 2 only when x sub 1 is equal to x sub 2. Let's have an example. Let's say the function is f of x is equal to x plus 2. First, we need to have this. F of x sub 1 is equal to f of x sub 2. Let's do substitution. So let x be x sub 1. So we have x sub 1 plus 2. And on the right side, let x be x sub 2. So we have x sub 2 plus 2. And as we can see here, both sides have plus 2, so we can just simply remove plus 2. So now we have x of 1 is equal to x of 2. Since we were able to show that the two x values are the same, when f of x of 1 and f of x of 2 are also the same, then the given function x plus 2 is 1 to 1. Let us now have another example wherein that function is not 1 to 1. Let's say we have f of x is equal to x squared. So same procedure to be done. Let us have f of x of 1 is equal to f of x of 2. So replace the x with x of 1 on the left, replace the x with x of 2 for the right. So we have this. How to get rid of the exponent, which is 2? We need to take the square root of both sides. And remember, in getting the square root of both sides, we have two positive values, which are positive and negative. And so, we have plus minus x of 1 and plus minus x of 2. So what's the meaning of this? We could have two values of x that will result to one y value. Let's say we have f of 2. 2 squared is equal to 4. And if we have f of negative 2, when you square it, the answer is also positive 4. With this, we could say that f of x is equal to x squared is not 1 to 1. At this time, let us now test your understanding. Answer the following items. Identify if the given is 1 to 1 or not. You may pause the video so you can answer these items. Let's check our work. First, it is 1 to 1. Second, it is not because as we can see for 6, it has two x values paired with it. Next, it is 1 to 1. And last, it is not because of 19 on y, it is paired with two values of x which are 9 and 8. How about this? Again, you may pause the video to answer the following items. Let's check it now. First, the function is 1 to 1. Second, the function is not. Third, the function is 1 to 1. First, it is not 1 to 1. And the second, it is 1 to 1. Were you able to answer all of the problems? If yes, great job. Here are the key takeaways for this lesson. When we say 1 to 1, it is a function for which every element of the range of the function corresponds to exactly one element of the domain. And we could represent it using ordered pairs, using graphs, and using functions. So always remember that for every y value, there should only be one x value. So here is the end of our lesson. Thanks for watching. I hope you have learned a lot in this video. If you're new to my channel, please don't forget to subscribe, Math Room by Teacher Joanne, and click on the notification bell to be updated. Bye everyone! See you in our next video.